So welcome to Pure Math 030. This is going to be an exercise on special angles. So a continuation of the previous lesson where we got comfortable with the special angles, hopefully. That is to say the 30 degree, the 45 degree, the 60 degree angle, or their radian measure counterparts in each of the four quadrants. Now these are very important and they take time to get good at, but you do run into enough of these in all sorts of questions in this unit. You have to get solid. So I'm going to refer back to those special triangles. I'm not going to draw them again, but you should get in the habit of keeping them in front of you. And the speed will build up. So these are also exact value questions because the whole idea with these special angles is that you are getting exact values. All those root 3 over 2's, those 1 over root 2's, your calculator cannot do them for you because it does not do exact values. So find the exact value of each of the following. Sine of pi over 4. Now I'm going to show you a variety of methods for these. Unfortunately, there's one specific method doesn't work for everybody. You have to find what works for you. So when I see a question like sine of pi over 4, I know that I'm given an angle, and I want to find the ratio. Now because this is a quadrant 1 question, you don't need to do a lot of extra work. And I've got a little grid in the corner, but really this is as simple as this. We have a pi over 4, which is a 45 degree angle in quadrant 1. So no extra work needs to be done with this. You simply have to take a look at those special angle triangles from the previous lesson and recognize that this is equal to either 1 over root 2 or root 2 over 2, depending on how you want to write it. I'm going to be consistent like this, but you don't have to do that. I know that that's a little confusing, but there's two different ways to write it. And I'll do the rationalized form for both sine and cos. And then that's it. We've got our answer. And I'm going to show you something else that might come in handy. This is a check on the calculator. I don't always do this, but I am this time. What you can do, either in rads or degrees, key it in. So I'm going to go into rad mode because that's the way the question was given, and I will work out the sine of pi divided by 4, making sure I close off that bracket. And let's see what we get. And you should get 0.7071. I'm taking it to 4 decimals just because that's all I need to compare, and that's very common. And now we compare with square root 2 divided by 2 on your calculator. See if you get the same answer. And we do. So it checks. So I know that I've got it. So even though these questions can be a little bit awkward and they involve some memorization, there's so many ways that you can use your calculator or use other sort of simple reasoning methods to confirm your answer that you should be getting them all right. Let's try another one that will force us out of quadrant 1. Cosine 210 degrees. So I look at this one, and I first off recognize that 210 degrees is going to take me into quadrant 3. So it's all about location. Moreover, Our reference angle, we're given, this is all in degrees, is 30 degrees. So make sure you get that. 210 minus 180, 30 degrees. Now, I'm going to be writing all these steps, but I want to remind everybody that these are 1-mark questions on the exam. By the time, when you get to this question at the unit exam stage, you should go from question to answer very quickly. So all the extra processes I'm putting here are unnecessary to show, but you are sort of thinking them. So internally, you're going through this. So what I'm going to indicate for this cos 210 is that this is the same thing as the cosine of 30 degrees. And we need to have it as our reference angle because that's what our special angles are. And this is going to be in quadrant 3. So you take a look at the list of special angles, and you recall that the cosine of 30 is equal to square root 3 over 2. So root 3 over 2, and then it's negative. And it's negative because we are in quadrant 3, and cosine is always negative. So that's what has to be done. And that's the right answer. If you do want to check, in degree mode, work out the cos of 210 degrees. Just drive it right in, and you'll get negative 0.8660. And then we know we got it, because that's what, if you went negative square root 3 divided by 2, this is a little bit tight at the bottom, but it should do the job, is also equal to negative 0.8660. So that is a check. You'll know you have it. Let's try another one. Tan of 7 pi over 4. So these are going to get progressively more difficult. And for the time being, I'm drawing little grids in the corner to help me get these angles. That is optional, but it's a nice idea. So here's the other choice that we have to make. Do we want to keep it in rads, or do we want to keep it in degrees? So the long method is to convert this into degrees. I'm going to do it for now, but I do want to, get us weaned off that eventually. Because that 7 pi over 4, I know is a quadrant 4 angle of pi over 4. So this isn't necessary, but I will just for old time's sake. If you did convert that, you would get tan of 315 degrees. And, and because you've just started working with rads, in most cases, it does take a while to be really, really comfortable. But most work beyond this course is going to involve radian measure for trig. So you have to get good at it. So that 315 degree angle gives us a reference angle of 45 degrees. Your thinking should be like this now. This tan of 315 degrees is really equal to the tan of 45 degrees in quadrant 4. So we get the ratio from the special angles at 45 degrees. And then we get the sine from the quadrant. The tan of 45 is equal to 1. But because we're in quadrant 4, it must be negative 1. And if you check this on your calculator, I'm not going to go through it, you will get negative 1. So tan or cotangent of 45 degrees in any quadrant is good news, because that's one you can use on your calculator. So even though I tell you that you can't use your calculator directly for these because of the exact values, that's only true for the root 2 over 2's and the root 3 over 2's, things like that. Let's take a look at another one. So finally, we're getting a reciprocal graph. And the secant of negative 240 is equal to 1 over the cosine of negative 240. So we don't need to worry too much about the secant. We worry about the cosine. And once we get the cosine worked out, we flip our answer over. It's just the reciprocal. Negative 240, because we're going the negative direction, is going to take us into quadrant 2. Now the negative 240 is just telling us the location. It's got nothing to do with the sign. Our answer could be positive or negative. It just depends on which quadrant we're in. So you really have to be clear on what you're looking for with these ones. And our reference angle is equal to 60 degrees off the x-axis. So in fact, what we care about in this question is the cosine of 60 degrees in quadrant 2. And the cosine of 60 in quadrant 2, well, the cosine of 60 everywhere is just equal to 1/2. So we got a break on this one. However, because we're in quadrant 2, it's going to be negative. And this would tell us next that the secant of negative 240 is therefore equal to negative 2. This is one you could have used your calculator on as well. So had you just keyed in 1 over cos negative 240, you've got the answer. And in my experience, a lot of people do use their calculators. One of the ways they do it is they memorize the root 3 over 2 as being 0.8660 and the root 2 over 2 as being 0.7071, and then they kind of work backwards like that. So I'm not going to say one way is better than the other. All I'm saying is that you have to find a method that works because you need to know them. And I'm showing you a variety of those methods. Try another one. Cosecant of 5 pi over 4 squared. So in case you have forgotten, when you have an exponent, it really means that this whole thing is being squared. And I'm going to do things a little bit different compared to the previous rad one. You could convert this into into degrees, excuse me. I'm not going to. I'm going to work it out in rads because that 5 pi over 4 I know where that is. And if you don't yet, you will soon. 5 pi over 4 is in quadrant 3, and it is a reference angle of pi over 4. We care about the reference angle. We don't really care about the original. We care about the reference angle, and we care where we are. Now, as you know, this is actually equal to 1 over the sine of 5 pi over 4, all squared. So I'm going to ignore that for the time being and just concentrate on getting the sine of 5 pi over 4. So this won't be as tidy as some of the earlier ones. The sine of pi over 4 in quadrant 3, well, sine of pi over 4, or the sine of 45, is equal to square root 2 over 2. But because we're in quadrant 3, it will be negative. So you take those two pieces of information together. And then now to find the answer, I simply take the reciprocal. So I write this as negative 2 over square root 2. Now this is the issue, right, with rationalizing. I will accept either, but what you'll get in this case is, you know, you had no radical on the top. But when you flipped it over, now you, or excuse me, you had no radical on the bottom, so when you flipped it over, then it ends up on the bottom. So when you're dealing with reciprocals, very often it messes you up. So if you did rationalize, I'm not actually going to bother with that. You would multiply by root 2 over 2. And so this is good enough. Let's take a look at another one. So they're getting a little more difficult. This one doesn't have a diagram with it, but that's okay because we're nice simple ones. This is the sine of 45 degrees squared minus the secant of 30, all squared. Now the sine of 45, if you were to take a look at your triangles, is root 2 over 2. And then all that is squared. And I'm going to note off to the side that the cosine of 30 is equal to root 3 over 2. So that would mean that the secant of 30 would be 2 over root 3, all squared. So when we evaluate this, the radicals go away because root 2 squared is 2 over 4 minus 2 squared is 4 over 3. Now, you know, this actually, I'm going to do something I wouldn't normally do, but I'm going to keep a denominator of 12 because that 2 over 4 is really 1/2. But I'm going to keep the denominator of 12, whatever. 4 times 3, 2 times 3 is 6 over 12. It's not going to make any difference. 3 times 4, 4 times 4 is 16. And that would give us negative 10 over 12, which is equal to negative 5 over 6. I would also encourage you to work this one out on your calculator. So I'll bring up a new screen and I'll do that really quickly. When you have these things that are squared, for your information, the radicals always would disappear, the square roots, so you can always solve them on your calculator. That's a piece of advice. So had you gone on your calculator in degree mode, had you gone sine of 45 close, close, squared minus 1 divided by cos of 30 close, close squared. Now, in fact, you didn't need those extra pair of brackets. Your calculator would have done it just fine with just sine 45 squared. But, you know, this is consistent with the way it was drawn. And you will see that you get an answer for this that matches what we saw before. So, being good at your calculator is a good thing with these. It can really bail you out of a few tight spots. Now, you will have to take that answer and turn it into a fraction on your fraction key, but you do get negative 5 over 6. Your fraction key, by the way, is located in the math menu if you weren't familiar with that. So this is on your calculator. And let's take a look at one more, then we can be done with it. So this one is looking pretty messy, but it's not that bad because it's all quadrant 1. And again, I will write this as the cosine of pi over 4. I'll write it in a more conventional exponential way. And this is a multiplication question. So that cos of pi over 6 times the sine of pi over 3. So the cosine of pi over 4 is in quadrant 1. It's a 45-degree reference angle, and the cosine of that is root 2 over 2, all squared. The cosine of pi over 6, cosine of 30 degrees, is square root 3 over 2. And then the sine of pi over 3, the sine of 60 degrees, is also root 3 over 2. So those numbers keep coming back at us. And then work it out. Root 2 squared is 2 over 4, so that's 1/2 again, plus 3 over 4. So root 3 times root 3 is just 3. 2 times 2 is 4. And look at this. 2 over 4 plus 3 over 4 is going to give you 5 over 4. And that's it. So that's how these ones go. Lots of practice, and you really want to take the time to get good at these. So thank you for your time.